Assalamu alaikum.
Um,
Good morning. Okay. All right. So maybe around, say, not even 24 hours ago, say 15 hours ago, we met and now we meet again. Right. So we discussed up until the components, right? And components,
yes.
how we can calculate the relative velocities, okay, and the maths of relative velocities and so on, so on. All right. Now, let us first of all, we will see the resolution of vector in three-dimensional coordinates. Okay. So previously, oh, sorry, there are some, okay. Okay, so there are some maths. Let us first check them. So a 30 Newton force is inclined at 60-degree angle with y-axis. Calculate the perpendicular components of the force along x and y-axis and find their addition and subtraction values. Okay. So if you would see a 30 Newton force and then the angle between y-axis and that force is 60 degrees. So if we try to draw it, it will be something like, so this is x-axis, this is y-axis, and then it's somewhat around 60 degrees, okay, which makes these to be 30 degrees, and this is 30 Newton. Okay, so now what is our question? Our question is that calculate the perpendicular components of the force along x-axis and y-axis. So that means forget about the perpendicular component, just focus on the term component. What is component? That means we will get a component along x-axis and a component along y-axis. So these two will be our answers. Okay, that is the thing. Now tell me, what is the angle between 30 Newton and x-axis?
30 degrees.
30 degrees, right? So that means the component along x-axis will be, or horizontal component will be
30 equals 30.
30 goes 30, okay. And for y-axis, it will be
30 sine 30.
30. Very good. Okay. So this will be our answer. Let's see what they've done. So, so they have done is p sine 60 degree. Okay. So they have like inverted the things. So not necessary. We will calculate the angle between x-axis and that particular vector. Okay. It will make our calculation easier. Okay. In this way you will get the same value, and they have taken sine and the angle with y-axis and that vector. Okay, that is why we the cosine and sine have changed. In case of x-axis we have got sine, and in case of y-axis we have got cosine. Okay, anyway, the answer remains the same. Okay, understand?
Yes.
Okay, now addition and subtraction, just add them and subtract them. There's no issue with that. Okay, pulling off a boat by a rope or towing a boat. Now, what do you think? Let me ask you a question. Say, this is a boat. This is a boat, okay? Okay. Now, say you have to pull it, okay? And here, I mean, here, say, this is the what the river bank maybe, okay? So now tell me, this is obviously the horizontal plane, and the person is here. Now, what do you think? What is the most suitable angle between the horizontal plane and the rope to work with? Based on your like experience, you don't have to like explain it to me mathematically.
Zero.
What do you think? It is
0
zero degree.
degrees.
Okay. Okay, very good. Why do you think so?
Because if you, I don't know,
You're actually
you
correct.
just
Okay, see.
pull it
First of all, let me show
and
it to you mathematically. So if I mean theta equals to 0 degree, or the angle between these two is 0 degree, then cosine zero equals to 1. Okay. That means in this scenario, horizontal component is the highest. Horizontal component is the highest in this case. Now, what do we want? What we want is that we want to take this boat to the river bank. Okay, that means we are like wanting to move horizontally. Obviously, we don't want to go in this direction, right? We don't want to. So we want to go in this direction. That means the more the movement is horizontal, the more it is like beneficial for us, right? So that is why this is the best thing. Like if the angle is like smaller, then it will be more helpful for us. Obviously, we might not be able to make the angle 0 degrees. So try to make it say 20 degree or 30 degree. But if we try to make the angle say 60 or 70 degree, it will be difficult for us to pull it. Okay. Understand? This is the like physical significance, and we will see it mathematical as well. Tell me, do you get my point?
Yes.
Okay, good. So let M
Mhm.
be a boat if at point O of the boat, a rope is tightly fastened and the boat is moving by the side of the river due to pulling it along or by a force F vector. So they have said various things and all. Okay. Now they have divided into components. Okay. Now O is the direction along the horizontal or the horizontal component's direction, and vertical component is F sine theta. Okay, along OB. Okay. Are you sick? Are you feeling sick?
No, I just
Huh.
woke up and that normally happens.
Okay, okay. So the vertical component is F sine theta and is acting along OB. The horizontal component of the force F cos theta pulls the boat. See, pulls the boat in the forward direction. And the vertical component of the force F sine theta pulls the boat towards the edge of the river. What do we want? We obviously want to go in the forward direction, right? Okay.
Yes.
But as in my case, I said that, okay, I want to get to the river bank, and river bank was in the front forward direction. So the scenarios could be different. Okay, you have to understand the like concept. Okay.
Okay.
All right. So now, but the rudder or helm of the boat balances that component. Okay. So which component is balanced? That is the F sin theta. Okay. So F sin theta won't be like much of an issue. Okay, because by this technique, the boatman would do something with this rudder that this F sin theta does not hamper our job. Okay, or the movement of the boat. Okay, so the larger the balance of the rope, the smaller is the value of theta. So if we want the balance of the rope, sorry, the length of the rope is like bigger, then it will give us more balance. How could I explain this to you? Say, for instance, say you have always doors, right? Not all the doors are sliding. You have some doors of wood, right, in your house.
Yes.
Okay. So now see, so this is a door. Okay, this is a door. All right. Now, say if you push it at this point, and if you push it at this point, in which scenario do you think it will be easier for you to push? So this is point A, and this is point B. In which point do you think it will be easier for you to push?
Point B.
Point B, right? So that is what they're telling us. Okay. So if the length or the point is distant from the like starting point, you could tell me. We will discuss about couple and moments. Then you will like get a better understanding of this. But for the time being, know that, see, in case of doors, if the point is like very distant from the where it's starting from, then it becomes easier for us to like close the door or open the door, right? With say lesser effort. Okay. The same goes for the rope as well. So if the length of the rope is large, say for instance, if it is small, then I can hold my hand up until here. But if it is long, then it's here. So that means the distance is greater from the starting point, right? So it will be easier for us to balance. Okay.
Mm.
All right. And also another
Yes.
thing is it will automatically turn the like value of theta to be closer, like closer to zero. Okay. Understand my point? Because whenever you are like working with a rope, you will take it to a full stretch, right? Okay.
Yes.
So whenever you are taking, say, a small rope, then you might be like, say, for instance, here at this point. But and you are here, say, for instance, okay. But if you have a long rope, then you might be at this point. Okay, the angle gets lesser. Okay. Understanding what I'm saying? This is like very fun concept to understand, right? We use it in day-to-day
Yes.
life as well. And we don't use it, the boatmen use it. And they might not even know the physics behind this or the concept of physics behind this, but they unknowingly use it. Okay. The smaller is the value of theta. So smaller is the magnitude of f sine theta, and larger is the value of f cosine theta. So obviously we want to go in the forward direction. So we obviously want the f cos theta value to be greater and the f sine theta value to be lesser. So that is why the theta should be as less as possible. So that is why we want as long of a rope as possible. So if you are studying in the college and you get some sort of question like this, will you be able to explain with diagrams and the logics? Tell me.
A good 90% sure.
Sorry?
90% sure.
All right, good. Mostly, okay, are you, okay, take notes of this. Mostly you won't get theoretical questions. Mostly you will get mathematics in physics, but sometimes there are questions which are theoretical. Okay, done.
Done.
All right. Now, again, a question towards you. I don't know if you have used a lawn roller or not. So, in case of like using lawn roller, we tend to like push it, right? Is that correct?
Yeah. What is
Okay.
a what
Now,
is a roller?
my question is, what do you think? What do you think? Is pushing the better way or is pulling the better way? Okay. What
What
do you
is a
think?
lawn roller?
What is a lawn roller? I mean, what is a lawn roller? Okay, lawn means lawn, right? And say we
Yes.
clean the grasses, right? Like cut them off the like our garden if they are like grown to be too much big. Okay, so then we use it, right? Some sort of a thing, something like this maybe.
Is that like something from the 1900s?
You could say that. You could say
Oh
that.
no.
Okay. But I think I mean it's still used, I guess. I don't know. It should be okay. Let
Oh,
me check.
okay.
Lawn roller. Yes, these are used.
Oh, those things.
Yes, they're still used.
Oh, those
Yeah.
are antique,
Yeah, could say that.
ancient.
Okay, okay, forget about
Anyways,
that. Say, for instance, you are using this to like carpet a road. Okay, so you are constructing a new road and then you want to carpet or like you have to like flatten the pitch. Flatten the pitch or bitumen you have put on the road. Okay, so that is more of a like logical thing, I guess, to you.
yeah.
Anyway, so now let us see what will happen in case of which case. Okay. So the first case here, okay, they have written all of things. Just see these two images. First thing is we are pushing. We are pushing it. Okay. So in case of pushing, uh, this is the angle. So this is the vector of our force applied, right? Okay. And we are considering the
Yes.
angle theta between the x-axis and this vector. So we get a component of f cosine theta towards the right or x-axis and f sine theta towards actually the downwards. Okay. All right. Is it clear? This one, this scenario clear?
Yes.
Okay. Now, in case of pulling, obviously you can understand that in case of pulling, see if this is our hand, see if this is our hand. If we're pulling this, that means the force is acting towards this direction. We are not like exerting some pressure in the ground, rather we're pulling it towards our hand or towards our body. Understanding my point?
Yes.
Okay. So now, then it creates an angle of theta again with the x-axis, and we get f cosine theta. And then f sine theta works in the upward direction. Okay. So this is the basic thing. F sine theta works in the upward direction if we are pulling. But if you are pushing, F sine theta works in the downward direction. That means if you would see here that W is the weight of the lawn roller, which is working exactly downward. Okay. And with it, also F sine theta, the vertical component is getting added. Okay. So that means that we have to put more force to move it forward. We have to put more force to move it forward because F sine theta is working against us and W is also working against us. W and F sine theta both are working against us. But
Okay.
in case of pulling, F cos theta is working for us and this F sine theta will nullify the weight. F sine theta will nullify the weight because they are working in the both direction. I mean, opposite direction. Okay. If they can't even nullify, it will somewhat reduce the like weight in the downwards direction. That will make it easier for us to move the lawn roller forward. Did you understand what I said here?
Yes.
So basically, the thing is, in case of pushing, the we are exerting a force on the downwards direction. That is why if cos theta is obviously in the forward and if sin theta goes downward. So it makes it difficult for us to move the lawn roller forward. And in case of pulling, the if cos theta is forward and if sin theta works upward, which reduces the weight or reduces the effect of weight. Okay. Let me give you a more easier example. Say suitcase, right? So obviously you've used suitcases whenever you have traveled. Okay. So now, in case of using suitcases, what do we do? Okay. We try to hold it as much inclined as possible. Okay. And all the time we pull it, right? We try to pull it. We don't push suitcases, right? Okay, maybe there are some
No.
kids who have fun like playing with the suitcase as a car. That's a different thing. But whenever we are carrying a luggage, we are pulling it most of the times. Okay. So this is the exact reason because it makes it easier for us to move it forward because this F sine theta, as you can see, it will reduce the heavy weight of the suitcase. Okay. Whereas if we were pushing, then it would have like what can I say, made the effect of weight even bigger. Okay, so which will make it difficult for us to push it forward. Understand?
Yes.
So we have discussed it previously as well, but obviously you had little to no idea about trigonometry then. So I hope it's easier for you now. And this copy of book is, I mean, present with you, right? You have it. So try reading
I
it.
think so.
Yes, try reading it. So
Okay.
then you will like be clear, more clear about the things. And another thing, did you manage to get the online copy of your book?
No,
Okay.
I
It
don't
should be
think
at
the
least
school is
available to
operational.
you, right? Even if I don't get access to it, you should be able to access it, right?
Like, I have a physical copy, but other than
Yes.
that, I can't really.
And that is what I was saying. Like You are in Australia. Australia is so developed and so digitally, what can I say, sustainable maybe, perhaps. So they should provide that opportunity for the students, right?
Yeah.
In our country, we have our government provides textbooks up until the 10th standard, that is school. So for that time, it's open for all. Like you can even download our books. Okay, for the English version and the Bangla version, both of them from the website. But from 11th standard onwards, there are like some copyright issues. So uh, there are like not only one textbook, there are like 8 to 10 textbooks, and whoever wants to read whichever book, they can read that. So that is why the PDFs are not available. Anyway, okay, so I hope you understand these. And see, total weight of the roller is W plus R sin theta in case of pushing. Okay. And in case of pulling, it is W minus F sin theta. Okay. So like this is how you could like explain it. And you will get obviously questions from there as well. Okay. Now in three-dimensional coordinates. Okay. Obviously, I've showed you already what the three-dimensional coordinates like seem like. Okay, it might feel to you like, okay, where is it, like z axis should be exactly upwards, but we cannot show it in the paper plane. That is why I told you an example of the corner of a wall. Here you will get x-axis, y-axis, and z-axis all together. Remember that?
Yes.
Okay, so try to remember that. All right, so now in case of any say three-dimensional vector, the way we try to show it is I hat x plus j hat y plus k hat z. Okay. So that means is that like coordinates will be given. Say x's value could be like 2, 3, 4 maybe. Say it could be 4. And y's value could be say 7. And z's value could be 8. Okay. So then the vector would become somewhat like r vector equals to. Am I going a little fast? You can tell me if I'm going fast. Okay.
No, we're good. We're good.
So it will be 4i hat plus 7j hat plus 8k hat. So based on the coordinates, we will be able to figure out the particular, three position vector. The position vector of a say object. It could be object or it could be a thing, anything. Okay. All right. Say for instance, a flying fly, a flying insect, you could say. A flying insect is, say, for instance, its coordinates could be presented as 5, 3, and 2. Now, I ask you to express its position as a vector in a I mean, three-dimensional coordinate system. So, it would be something like p vector equals to 5 I cap, because this is the x-axis coordinate, then 3j cap, and then 2k cap. Okay, so it should be fair and clear up until now. It's like very simple things.
Hmm.
All right.
So I, J, K cap are
Yes.
equal to the X, Y, and Z coordinates.
No. I is the unit vector along x-axis. Okay. I is the unit vector. I hat actually unit vector along x-axis. J hat is the unit vector along y-axis. These 5, 3, and 2 are coordinates. Okay. If ij and k are coordinates, will you be able to figure out the uh, I mean actual position? The answer is no. Okay, you cannot get the position with those sort of coordinates. Coordinates have to be in digits. Okay, and k hat is unit vector along z-axis. Right. Done.
Yes.
Let OX. Okay. All right. So they have like proved it how you will get the position vector of R vector equals to xi cap plus yj cap and zk cap. Okay. Anyway, let's see. Okay. So while expressing a vector quantity with its, okay, sorry, we have already read that. So let OX, this is the OX, then OY and OZ be three lines perpendicular to one another. That means that the angle between OX and OZ is, what is this angle?
Um,
Tell me. I have told you this the previous day.
uh,
Okay, look at the corner of your wall. Look at the corner of your wall and tell me what should be the angle between OX and OY, or sorry, OX and OZ.
90.
It looks
Oh,
somewhat like
45.
this. 45 degrees. How?
Or I just remember something called something like 45
I mean,
last time.
what is the reason behind that? Like,
I have
why
no
do you
clue.
think it's 45?
Let
It's
me see
already,
real quick.
even if you say, if you have forgotten, see, OX, OY, and OZ are perpendicular to one another, right? What does
So
this
that
mean?
would be 135.
What do you understand by the
Oh,
term perpendicular?
um, that it can be equally adjacent to each other.
What? That is not what perpendicular means. Okay. Okay. Say a right angle triangle. Okay. Right angle triangle. A, B, and C. We say that AB is perpendicular to BC. Okay. AB is perpendicular to BC. So perpendicular means that any two lines who have a 90-degree angle between each other. Okay. Right. Whenever you will see that the perpendicular term is involved between two lines, that means the angle between those two lines would be 90 degrees. And what does parallel mean? What does parallel to one another mean? Tell me. You have to
That
be clear
is
with these concepts. What does parallel to one another mean?
where two lines share 0 degrees.
Two lines
Like,
share 0 degrees. What does that mean?
I don't know, okay.
You
Like
have to know, it's like,
they're in the same
I know you
direction.
have read this before. That is why I'm asking. And you
They're
might have
in the
read
same
this like
direction.
3 or 4 years before. Okay. So what are the parallel lines? Parallel lines mean that these are two lines. Okay. One line, two line. Okay. So the characteristics of them are the angle between them at each and every point would be 0 degrees. Whichever point you take between these two lines, the angles would be 0 degrees. Okay. And they won't coincide or intersect with each other. Okay. And this perpendicular distance, see, the perpendicular distance between these two at any point will remain the same. Okay. All right. So I haven't been reading this all these years. Okay. I have read this in sixth or seventh standard, which is like, say, for instance, from 8 or 10 years ago. But I cannot forget this. These are like basic things. You have to remember them. Okay. You have to like say it within a second. Okay, vaya, okay. Parallel means there are like there will be a 0 degree internal angles between these two. They won't intersect with each other. If they will go till infinity or limitless, but they won't intersect with each other. And the perpendicular distance between these two on each of the points would be like same. Okay, you have to be this fluent with these terms. Okay,
Okay.
I did not know that you don't know about perpendiculars. If even if you don't know, like, don't
I
feel shy to. Obviously, I'm here to explain these things. If you don't understand what perpendicular or parallel means or any term, you could like ask me. All right. Anyway,
Okay.
now tell me what should be the angle between OX and OZ?
Damn it. OY.
OX and OZ. What is the
OX and
angle
OZ.
between them?
What is
I have
that?
all I have
Oh,
already said that it won't look like what it's being been seeing in the paper plane. Okay, so that is why I told you to look at a wall's corner where some sort of three lines meet. Okay, so these are the two lines, and they are like exactly towards the upwards direction another line goes. Okay, so what are the angles there? OX and OZ are perpendicular to each other. Do you understand that? Say this is OX. Okay, this is the point O, and this is X and Z. So look at your like wall plane. Okay, okay. Let me show a picture of you. Yes, that would be. See, say Okay, I think that one would have been better. This one. See, what I am saying to you is, see, this is the say y-axis. Okay, in this direction. This is x-axis, and this is z-axis. Now tell me, what is the angle between x-axis and z-axis now here?
90?
90 degrees, right? But does it seem
Yes.
like 90 degrees? It doesn't. But the angle is actually 90 degrees, right? Obviously, because we try to make the walls like in a rectangular shape or something like that, a cubic shape rather. Cubic or like rectangular cube, say for instance. Forget about the terms, 90 degrees. Now, what is the angle between z-axis and y-axis?
90.
90 degrees, right? And what is the angle between x-axis and y-axis?
90.
90, right? Same is the case here. Same is the case here. We have to visualize it because it's not possible for any human being to draw a three-dimensional thing in a two-dimensional space. Okay. So that is why you have to like visualize it. And as I'm saying, this is just only the beginning of visualization. You have to visualize various things. Okay. Anyway, so this is 90 degree. And what about OY and OX? What about this angle?
90 degrees.
And what about this angle?
90 degrees.
Okay, so all of them are 90 degrees. Good. Okay. Now they have considered a vector R vector to be presented by line OP. Okay. So this is the position vector. Okay. Or you could call it a radius vector as well. And the coordinate of this point P is X, Y, and Z. X coordinate is X, Y coordinate is Y, and Z coordinate is Z. Okay. Hmm. And I, J, K are the unit vectors along the axis X, Y, and Z respectively. Okay. And here Pn is drawn normal to plane XY. What is normal? Is
Um,
it like normal water?
2.x1. No idea.
No idea. Do you say? If I tell you to like recall, have you never heard the term normal? Like of like reading for say 15 or 16 years for the mathematics. What do you think?
I
Have
don't
you
think
heard that?
so.
Okay. All right. So okay, it's actually the same to like perpendicular. Okay. So it's also a 90 degree. Okay. So see, if from P point, if a normal is drawn to XY plane, that would mean that the angle between the XY plane and the normal would be 90 degree. Okay. 90
So it
degrees.
would
Right.
be perpendicular.
Yes. All right.
So when they say perpendicular?
Perpendicular is said when like we are drawing say two lines which are perpendicular to each other, but here we are drawing from one point. That is why we are saying that normal is drawn. Okay, in case of points, you could use it interchangeably. There is no problem with that. Okay, now from see if we use the triangular formula or triangular law, what will we get? So OP vector equals to ON vector plus NP vector. How is this correct? You will explain it to me. Why is ON vector plus NP vector equals to OP vector? Tell me.
ONOP.
ON plus
Wait,
NP equals to OP. Why?
ON plus OP equals to NP. From the, what was it called? Something vector. Uh,
Say I am
Addition
your
of vector.
student and you are teaching me. Okay. So explain it to me in that way that I
We
understand
can
everything.
use the addition of vectors to calculate this. So if one vector ends on a point, the other vector must start on that same point. So if we go from damn it,
Okay. So
ON.
you were so you were saying that okay, addition law of triangles, right? So you have to start from one particular point and then a vector ends at that point. And from that particular point, another vector starts and ends at another point. Now, if we add these two vectors, it will equal to the first vector's first point and the last vector's last point connected. What did I say? First vector's first point and last vector's last point connected with each other. Okay. So that will be the addition law. Okay. And you have read it in mathematics as well, I guess. Okay. So you have to be able to figure these out. All right. All right. Let me give you another link. Okay.
Okay.